Hey, thank you for that introduction. Hello, everyone. Yes, I'm Neil Trevitt, and I work on developer ecosystems at NVIDIA, and I'm president of the Khronos group. This presentation is going to give you the latest updates on Khronos open standards used for building virtual and augmented reality, or XR, experiences, and how those standards work together with the larger constellation of standards throughout the industry to enable XR developers everywhere. So let's start by introducing Khronos. If you haven't come across the group before, we are an open standards organization. We are focused on creating interoperability standards to enable applications to access the power of silicon acceleration for domains such as 3D graphics, virtual and augmented reality, parallel computation, and increasingly vision and inferencing acceleration. So we are a non-profit organization, and all the standards we create are open and royalty-free for the industry to use. We've been working on standards for 20 years now and have almost 160 members, everyone from NVIDIA, Valve, and Google, all the way down to small startup companies spread across the world. We are open to any company who wishes to join to have a voice and a vote in how any of these Khronos standards evolve. So let me start by reviewing what are the most active standards currently being developed by Khronos today. There are 4 main groupings: 3D acceleration APIs, including Vulkan, OpenGL, and WebGL. Initiatives concerning 3D asset formats, including GLTF and the new 3D Commerce Working Group. The OpenXR API standard for portable, augmented, and virtual reality. And lastly, APIs and languages for parallel computation. I'm going to focus today on those highlighted standards that are most relevant, I think, to this VR and AR audience. And I'm going to start with Vulkan. So Vulkan is a new generation API that provides low-level explicit control over your GPU hardware for the highest performance and lowest latency 3D graphics and compute. Vulkan is unique. It's the only open standard new generation GPU API, and so it's not restricted to ship on only one vendor's platform like DX12 and Metal from Microsoft and Apple. Vulkan is now being shipped by every GPU vendor. It's being adopted by the leading gaming and application engines and is available on pretty well every platform, including desktops, mobile, consoles, embedded systems, as well as the cloud. So although native Vulkan drivers are not possible on macOS and iOS, there are solutions that enable Vulkan applications to even run on Apple platforms. So if you want to develop the highest performance, lowest latency XR applications, and you want to deploy your application portably across almost any system, then Vulkan is the 3D API for you. Next, I want to talk about OpenXR, which is Khronos' open standard for cross-vendor, portable, augmented, and virtual reality. OpenXR defines a common API that all XR hardware runtimes can expose to application and engine developers. This enables engines and applications to be written once and then run on any XR hardware that supports the OpenXR API. As well as providing that portability, OpenXR has enabled the industry to come together to learn from its first generation proprietary APIs and to collaborate to create a new generation XR API with cutting edge capabilities. OpenXR enjoys the support of pretty much a who's who of the leading AR and VR companies throughout the industry. So OpenXR contains everything an application needs to drive the XR devices in the system, including device discovery, event processing, sensor tracking, pose calculation, they're all on the input side, and frame timing and composition, plus haptics control on the output side. The only thing that OpenXR doesn't have is 3D rendering. And so an OpenXR application will use a rendering API, such as Vulkan, to generate imagery. Any 3D API, but the new generation API Vulkan is particularly well suited to create applications with the high rendering performance and the low latency that are so vital to a compelling XR experience. So OpenXR is pretty early in its rollout, but an increasing number of implementations are beginning to ship. The 1.0 specification was publicly released at SIGGRAPH 2019, that's mid-2019, and was supported from day one on Microsoft HoloLens 2 and the Monado open source XR engine from Collabora that runs on any OpenHMD compatible hardware. Since then, OpenXR has shipped on Microsoft's mixed reality headsets, the Oculus Rift and Quest HMDs, and is available as a plugin to the Unreal Engine from Epic. Plus, there are many more implementations in development and on the way. In parallel, the OpenXR working group is finalizing the API's conformance test suite that will ensure consistent portability across all of these multiple XR implementations as they roll out across the industry. I think the reason that OpenXR is gaining such wide industry adoption is that it's a win-win for everyone involved. Software developers or ISVs, they win because they can write an application once and ship on multiple hardware platforms without reporting. That saves them both time and money and lets them reach a much larger audience. XR hardware vendors win if they expose the OpenXR APIs on their platform, as they have access to a much larger library of OpenXR compatible applications. And most importantly, end users win because they know the XR applications that they want to run will be compatible with the system they have just purchased, growing end user confidence and growing the XR market for everyone. So far, we've talked about Vulkan and OpenXR, which are both native APIs. However, the metaverse, which I call this openly connected and searchable virtual spaces and assets, is likely to evolve out of the World Wide Web. And so it's critical that the industry also bring this XR capability to your browser. The good news is that Khronos and the W3C, that's the World Wide Web Consortium, a sister standards organization, are cooperating to bring 3D and XR capability into the web stack. All 3D in a browser today uses WebGL. That's a Khronos standard that defines a JavaScript binding over native 3D APIs, and which is used in popular 3D web engines such as 3.js and Babylon. Now, we also have the OpenXR native API exposing XR hardware capabilities, and Khronos is working closely with the WebXR working group at W3C to bring that capability into the browser. So just as native XR applications can use Vulkan and OpenXR together, XR apps in the web can use WebGL and WebXR together, with the web APIs reaching down into the Khronos native APIs for acceleration and hardware portability. As well as providing application portability between different HMD devices, OpenXR will also provide portability for AR as it's deployed on new platform architectures, such as edge servers. One architecture being developed uses 5G to connect a lightweight AR device to send its real-time sensor data to an edge server, such as an NVIDIA EGX platform that processes that sensor data, maybe using advanced acceleration for inferencing, generates graphical augmentations, and they can be much more sophisticated than can be generated on a battery-powered device, and they are then sent back to the device for display. The key thing for portability is that the OpenXR API can hide these round trips over 5G from the application, enabling the same AR application to run either natively on an AR device or an AR device connected to an edge server. So next, I want to talk about every XR needs to access and display 3D scenes and objects. So I want to talk about GLTF. This is a Khronos standard. It's not an API. It's a 3D asset format that is focused on being ubiquitous, compact, and easy to process. And so we like to call it the JPEG of 3D, as is the last mile JPEG equivalent that lets you easily transport and deploy and use your 3D assets wherever you need. GLTF uses JSON to describe the 3D scene or asset hierarchy, and uses binary payloads to describe the data-heavy geometry, animations, and skins. Textures are typically JPEG or PNG files, The latest version of GLTF, which is GLTF 2.0, has PBR, or physically based rendered materials, that use those textures to map how metallic or rough materials are, or how specular and glossy. This results in very realistic looking objects that can still be rendered very efficiently, even on mobile devices. And this rotating object you see here, this is standard PowerPoint. PowerPoint now supports Khronos GLTF, so you can insert and animate 3D objects in your PowerPoint presentation. So support for GLTF is now very widespread throughout the industry as companies realize the efficiency and the cost savings of having tools, apps, and engines that can all communicate assets easily to each other. All the companies and products shown here have all implemented GLTF support, both tools that generate GLTF assets, and engines and applications that ingest those GLTF models. So if your company supports GLTF and your logo isn't here, please let us know. Actually, we would love to add it. Keeping the slide up to date is a full-time job, but it's a good full-time job. So GLTF is evolving to meet industry needs. It's very close to finalizing GLTF universal textures for efficient and flexible texture compression that complements the existing Draco-based mesh compression extension to enable very compact asset files. Universal textures use Basis Universal, is a royalty-free encoding and transcoding technology from a company called Binomial, with a KTX2 wrapper to provide consistent cross-vendor access to texture assets such as map levels. This enables smaller than JPEG textures that are directly transcodable into almost any GPU-accelerated texture format on the fly, so textures never need to be stored as fully decompressed images on the GPU, saving a significant amount of GPU memory. Next up on the GLTF roadmap is second generation PBR that's going to define advanced material properties such as absorption and anisotropy. This will start shipping soon as a series of extensions starting with Clearcoat. They've been designed by actually a pretty amazing group of expert companies that are guiding the GLTF standard to a sweet spot between visual realism and widespread deployability, creating a ubiquitous PBR format. And now, due to GLTF's success, lots of incoming feature requests, the GLTF working group has the interesting task of finding the right balance between adding more functionality, but keeping GLTF focused on its primary mission of being a ubiquitous 3D delivery format. A lot of these discussions are happening on the open public GitHub. So even if you're not a Khronos member, please give us your input. The last topic today, as I'd like to talk briefly about the most recent initiative at Khronos that will positively impact XR, the recently formed 3D Commerce Working Group. The basic technology to use AR in online retail has been around for many years. For example, this is an IKEA AR furniture shopping app that shipped back in 2013. And such pilot projects showed that the AR was indeed an effective technology for driving customer engagement and increased sales. So why isn't 3D commerce more ubiquitous today? Many in the 3D commerce industry have realized that in addition to having the right acceleration and portability APIs, the main barrier to rolling out 3D commerce at industrial scale is the process friction around hundreds of companies trying to cooperate over the design and manufacture and presentation of millions of products across multiple platforms. If you talk to online retailers trying to use 3D models, there are so many horror stories, from the complex down to the seemingly trivial, such as no one can agree what direction is up for 3D models, which sounds trivial until you think what that actually means to a retail website that's trying to import thousands of models every day. The desire to solve these 3D commerce process issues prompted a number of retail companies such as IKEA, Amazon, and Target to approach Khronos as a safe space to cooperate and where there is already considerable 3D expertise. We want to create standards and guidelines to enable 3D commerce at industrial scale. We now have a strong quorum of participants, including a unique mix of retail, technology, and platform companies working together to enable the widespread use of 3D in retail. So the 3D Commerce Working Group is working to ship initial guidelines and standards this year. Some are coming out quite soon, solving the first round of these urgent process issues around creating and configuring and displaying assets. ensuring that they can be faithfully displayed with sufficient visual realism regardless of the end user's device. This work is leveraging and inspiring GLTS evolution, including GLTS new generation PBR model that is going to be used to accurately display a wide range of products. Streamlining the creation and deployment of 3D assets at scale is not just going to enable 3D commerce, but it's also going to have a deeply positive impact on deploying all types of XR applications and solutions. So that's my presentation. I hope you found it interesting. If any of these Khronos standards are relevant to your business, any company is welcome to join Khronos to have a voice and a vote in our evolution. Annual membership starts at $3,500 for smaller companies. And if that is too much, you can apply to join one of our advisory panels that provide requirements and specification feedback to the working groups themselves. I've provided some links here in the slides. I will be happy to answer any questions here on a session now. Thank you.
Thank you for a great presentation, Neil.
You're welcome.
And unfortunately, we have only time for one quick question and quick answer. I had an interesting question from Nico Korolog. Could you integrate this system with a blockchain or DAG for tracking asset rights?
That's a very interesting question. The first round of guidelines that's coming out of the 3D Commerce Working Group is not going to be using blockchain. We're focused on what we consider to be the most critical issues first, and that's the tool chain on creating assets, tagging the metadata, getting the model representation correct so they can be handled consistently throughout the whole distribution chain. There are so many clear and present opportunities to help clear out that process and to enable a lot more efficiency in the 3D commerce distribution channel. That's where we're starting. It's certainly a possibility that we might use blockchain down the line. But that's a discussion for maybe version 2.
Okay, doke. Thank you, Neil.